everybody. You might be wondering why I'm wearing these interesting glasses. I'm here with Ashley McLeod. She's an upper school science teacher, and she is going to show us a little bit about some of the applications that our students are actually doing in class. At Bowles, it's really important that we're obviously disseminating information, but at the same time, we want students, doing hands-on experimentation and learning the applications in the real-world environment. So, thank you for coming in. So, tell me, what are we looking at here?
We are looking at hydrogen in a discharge tube. So, we have hydrogen gas inside this glass tube. We're applying high-voltage electricity through it to excite the electrons. The electrons are jumping from their ground state energy level up to an excited state, and depending on the amount of energy that they're absorbing, they will go up to different levels of excitement. And we are actually measuring, you can see them with your glasses, the different colors, the
wish
spectrum.
You guys could see through this. Maybe you can use the lens to go through, but you get the spectrum of colors. Bright red line, a bright teal line, purple line.
And then what we did is we used this new device that we just got in this year, a spectrophotometer, where we scan the actual light being given off.
Okay.
And we actually pull up the actual wavelengths of light that you saw. So those red and teal and violet lines are actually showing up, and we're measuring the actual wavelength that we are seeing through the glasses. We're going to get that actual wavelength. And so we did this with many different elements. And then we actually scanned the light in the ceiling. And I asked my students to use the data from all the elements that we had analyzed to tell me what element is in our light bulbs in the ceiling.
That's cool. So this is like an individual fingerprint?
Yeah, it is. It's a fingerprint. And you get every element that we put in there, we get different colors. So, it'll show off peaches and blues and...
Okay, so I'm tracking you now. So tell me then, as you extrapolate out, how do you introduce this into sort of their real world to give them a context of what
some of them, they already have an idea of what this is. They've seen this in the everyday world. This is neon lights, except this is hydrogen inside.
Got it.
But what they've seen is neon is going to be a red light.
Okay.
And that's what they've seen around. But like when it's different colors inside those tubes, that's actually a different element or compound inside those glass tubes. So it's used for science, but we can use this to understand more about the atom and its structure, which is going to be a big foundation in further units when we talk about bonding and chemical reactions.
Sure. So how would you describe what is chemistry? Chemistry is...
It's basically the study of matter. So anything that matter does, it changes, just like how it is, just right here in front of us, the changes that it undergoes, like the transition of energy through the matter, and it's magic.
No,
it's really what it is. It's like
fantastic.
The study of, it's like, you look at something like this, you're like, it's magic, but, there's science behind it.
Right. Well, it's fascinating to me because, like just about everybody else, I took chemistry when I was in high school, and I don't think they did as great of a job of explaining the why. It was just kind of like, this is what it is, and you're looking and you're like, that's really cool, but you don't understand how it is affecting or is part of the composition of the universe. So you could actually use this to go through and trace molecules anywhere.
Yeah, so scientists actually use this to see like what gases are present on stars, and like in our different atmospheres of celestial bodies. So like if you send a probe out to Jupiter or Saturn, those probes, a lot of them don't come back. They get sucked into the planet, but they can send back information like, instead of taking a sample, instead they can actually analyze the light that's being given off, and we can analyze what's going on just in the atmosphere.
That is crazy. That is
so cool.
I know, it is cool. And so what was the impetus behind, like, I know that, this technology has been around for a long time, but you mentioned, the, what is it? I want to call it the flux capacitor, but it's not a flux capacitor.
A spectrophotometer. So it basically measures light, like the different light waves that are coming through, and these are components. So like right now you see like this kind of hot pink coming off, and that's what your eyes pick up, but it's actually a combination of that bright red line, the blue line, and the violet line all put together. So just like when you see white light, it's actually just a combination of all the colors of the rainbow. So what your glasses are doing is just separating it into its component colors. And we felt that like this particular chapter is very abstract, so we wanted something that could help them wrap their heads around it and their hands, like they could actually, see it in a better light.
Yeah.
No pun intended.
No pun intended.
But then this can actually be used for other applications as well for throughout the year. Like we can use this for like doing calibration curves of solutions and concentration. So like this device actually has a lot of applications throughout the year.
I think it's fantastic. I mean, for me as a student, personally, anything that I was going to do that was more hands-on, where I was actually working with instrumentation and measuring, was always going to be better than just, sitting down. And I remember a lot of bonding and ions and all kinds of things, and it just didn't grab me. It didn't make sense until this makes far more sense when you explain it.
Kids are very visual.
Yes.
You're going to pick up on it better.
Awesome. Well, now we've got the lights back on, and I took the glasses off, so I can't see the aura that is there, which is really cool and enticing. But I really just want to say thank you. Thanks to you and your colleagues and for doing this and making it real and making it applicable to our students, and keep up the great work.
Well, thanks for having me.
I mean, this is super fun.
I love sharing this.
This is kind of our first time that we've taken me back to class. It's always been sort of more of a lecture delivery format, which we don't do all the time here. And so this was really nice to see that this is the case. I bring some more experiments in, and
Yes.
thank you. Oh my gosh, I got her all excited. She's good. So, but thank you, and thanks to everybody out there for all that you do.